Testing, testing. Folks in the chat hear me? Okay, let's get started. So, as always, remember to do your seating survey. This is section 4 today. I sent around a notice about this, but just to make sure, please do not send me emails about things about the class. Send the stuff to Piazza. When there are a bunch of things happening simultaneously, I'm keeping up with what's going on in Piazza. And then I think I've got everything done. I check my email and I find 40 more things that are listed there. If you send me stuff through Piazza, that is the easiest way to make sure that that I'm going to be seeing it in a timely fashion. Remember, just as a reminder, you can post anonymously there. You also can send a private message to me through Piazza. Okay. Small group activities. I went over this some yesterday as well, but I know that not everybody goes to every class session, so I'll go over it again here. This time around, it was a logistical nightmare because of a variety of things. Group members very often weren't talking to each other early enough to schedule when they were going to be working together. Some group members were submitting an assignment for the group before actually having talked to anybody else in the group, which is a problem. And people saying that they only found out that it was due a few hours before it was due. I will point out that I had multiple Piazza posts about it, announced it in class daily. The calendar and the gradebook and Blackboard tell you when it's due. So I don't know how to be more clear about when things are due on those. And that's a small list of the kinds of things that were going wrong. So a lot of the problems, I think, were coming down to groups not figuring out how to work with each other very well. And so when there is a problem with your group, there is a question on the individual quiz, which was due yesterday, that is open-ended, and you can tell me anything you like about what happened that time when working with it. And I take those responses into account when I consider, people getting credit for the assignment, and in extremer cases, even mixing groups around, switching people from one group to another group. I say here I'm in the process of adjusting groups based on the responses to this question. I actually just finished it about 5 minutes before I walked out the door to head over here. So the idea was that in groups where some people were non-responsive to to people in the group, split those people out, and we'll put all the non-responsive folks into groups together. And people who were being proactive and getting frustrated dealing with the other people that were in the groups that weren't responding, let's put those proactive people together. And remember, when you are describing to me what you've done to try to connect to people, I can see your discussion boards. So I can tell whether you've tried to reach out on that forum. So I have made it through all of the individual quiz submissions that happened, and I've adjusted the groups based on that. So make sure you take a look to see what group you are now in. A lot of groups stayed the same because they were, in fact, working well together. Some groups had a minor problem, and so there might be some minor tweaking, and in a few cases there was some major shuffling. So my hope is, having now done this once, I won't have to be doing much shuffling again in the future, so that this will be consistent from here on out. Going forward, I know this time around I said if people need to, because of not being able to get in touch with members of your group, go ahead and submit an individual response if you feel comfortable doing that. That's not going to be allowed in activities 2 through 6. These are designed to be group activities, and that they need to be group activities. 1 submission per group. If you submit without consulting the rest of the group, and I hear from the rest of the group that you didn't consult them before hitting the submit button, you're going to get a 0. If you don't participate in the discussions and thereby hold up the submission for the group, you're going to get a 0. I'm going to evaluate these sorts of things case by case, based on that quiz question that comes in. I know a number of people asked about whether the Blackboard settings could be changed to allow email notifications for a new post to the group discussion boards. I think I have successfully done that, so you should be able to do that now. But I can't see it from your perspective, so if you can, if anybody that's interested in trying to set that up for themselves to get those kinds of posts, if you can let me know if it works or not, I'd appreciate it. Don't forget to do the quiz. A lot of people didn't do the quiz. That's how you get the points. The whole idea of the activity is that you work together on the activity to come up with the answers, but there are 80 of those. And there's no way for me to grade in a timely fashion 80 full Google Docs. So the quiz is how your answers get checked. So make sure you do that. And it is the submission deadline for the Google Doc is Tuesday at 5 p.m. That is hard and fast because the quiz opens up right after that. The quiz opens up at 5 o'clock on Tuesday. It is due 5 o'clock on Wednesday. And that is a hard and fast deadline as well, because as soon as 5 o'clock on Wednesday comes around, quiz submissions stop, and the key for the group activity becomes available. Okay, so those are fixed deadlines. There was apparently a problem with the quiz this last time on partial credit. I have gone in and fixed that so that answering part of the question correctly will now give you the correct number of points. And I was impressed that Blackboard was able to retroactively grade everybody's without having to resubmit. So that problem should be fixed. Okay. Some trends that I noticed. There were some groups that used Zoom. There were some groups that asynchronously used the Google Doc. There were some groups that asynchronously used the discussion board. The groups that used Zoom, almost across the board, expressed a much greater satisfaction with the experience and the brainstorming and the ability to learn from the activity than did people who tried to do it asynchronously. This is, I anticipated that that was likely to be the case, which was why I so strongly recommended that the Zoom method of interaction be your top choice. Just if you felt like you had a bad experience with it, keep that in mind and maybe see if you can talk your group into moving more in the direction of a Zoom interaction. Another trend I noticed was that groups that started the week before the activity was due had more back and forth to be able to get the right answers with each other. They were able to spend some time thinking about the answers and not just try to rush through it and get everything done at the end. Most students that did the activity expressed that they felt that doing the activity helped solidify their understanding of the material, which I found great because that's the goal. The goal here is for you to take the main concepts we've been talking about in class and then apply them to a new kind of situation. There were several sort of wrong approaches that were described, and wrong approaches in my opinion, that were described about how people were trying to do these. The first one was dividing up the questions among the group members. I strongly recommend against dividing up the questions. These activities are designed to be an argument that follows from beginning to end of the document. The questions are leading you through the steps of that argument. And so question number 5 won't make sense unless you have already gone through questions 1 through 4. And so the intended way to do these activities is for the group together to look at question 1, read through it, read through the background material, and discuss what the answer to question 1 might be and come to a consensus on it. Then once they have that consensus, move on to question 2, and then arrive at a consensus at question 2, and so on. This is essentially a Socratic method style of teaching, where as Socrates did in ancient Greece, where you are led through an argument by questions being asked to you. And because it is an extended argument, you can't just treat the questions as being independent of each other. The second thing that people expressed was that, a few people expressed was, you know, I don't feel like we covered this material. I didn't know where to go to look up the answers. Well, the reason for that is this isn't a look up the answers kind of activity. This is a take the ideas that we have been talking about and apply it to a new situation. So even though this activity talked about micelles, you didn't have to know anything about micelles before coming into the activity. There's enough information provided in the activity for you to figure out what a micelle is, and then be able to answer the questions based on that. The notion here is that you're constructing an understanding of the material based on the background I give you in the activity, and then based on the brainstorming that you do about that information as you work towards answering the questions. Okay, so that's enough on the small group activities. The next one is due next week, and then we're going to have a break from them for a little bit after that. The groups have changed a little bit, so make sure you check to see who your group is this time, and get started on figuring out your logistics early. Okay, upcoming deadlines. Tomorrow at 5, as usual, homework is due, homework number 3. And just as a reminder, there's no supplementary question this time. And then Tuesday of next week at 5, the small group activity number 2 is due. The quiz on that one will be due the Wednesday immediately following. Do we have any logistical things that we should chat about before moving on to any of the content? Yes. Format of the test, okay. It's going to be an online test. I am anticipating in my weekly announcement email or post that I'm going to put up tomorrow to be able to give you a lot more details about that. The general idea is what I'm hoping to do is to write the exam so that it can be open book, open notes. And I'm going to sort of estimate how long I think it should take people to do, and I'll probably give you double that amount of time to be able to do it. And then I'm hoping as well to be able to set it up so that over like a 3-day period, you can take it in any window during that 3-day period. Setting up the exam this way means that that I'm not going to be asking you questions, do you remember this detail? Or here is a numerical problem to solve that is exactly like an example problem that you've seen just with numbers changed. Because that's just testing you on whether you can look up the right stuff. It's not testing your understanding of the material. So instead, I'm going to be asking questions that are going to be more testing your understanding of the material, where you're having to take the concepts and apply them to something that is a little bit different from what you have seen before specifically. Okay. In yesterday's class, I went through an extended example of that. The timestamp index includes some comments about that. The example I went through was, imagine you have a lattice, a simple cubic lattice of anions with a known radius for the anions. And the cations are fitting in the octahedral interstices in the middle of the unit cell cube. What is the largest cation that could fit in that structure without expanding the anion lattice? Okay, so that is not something that we have directly solved. Well, I mean, we did yesterday because I went through that as an example, but that's not the kind of question that we specifically solved, but the concepts that go into solving it are exactly the same concepts we've used to determine things like packing density and the geometries of the unit cells and those sorts of things. So those are the kinds of things I'm going to be doing. And so for each of the sort of main topic areas, my hope is that I will be able to come up with like one main system to have you talking about. So all the unit cells type stuff, I'll give you one system to be thinking about, and then I'll ask a bunch of different questions about that one system. So even though it may be a slightly new system to you, you only have to figure it out once, and then you are addressing multiple questions to that one system. Does that generally make some sense? Okay, yes?
So will the questions be multiple choice so that you get a grade on that?
So there will certainly be some multiple choice. There will certainly be some numerical calculations, and so there'll be a range of correct answers that you could put in. So keep track of when I say to give me a result for a density in grams per cubic centimeter, make sure that you get your units right when you do that. There may be some sort of, matching or ordering kinds of things going on. Just from a trying to catch up on grading standpoint, I don't anticipate asking essay questions this time around because I know I'm behind on earlier gradings that I need to be getting back to you guys. I tend to like asking sort of an explain this kind of question because that probes your understanding of the material better than a multiple choice kind of thing can. But just from a realistic standpoint of trying to getting you results back in a reasonable fashion, I suspect I won't be doing that for exam number 1. Anything else? Logistics we should chat about? Anything from the chat?
You haven't set a date, right?
I have not set a date. So it's supposed to be after next week, I believe. So next week is the last set of material that is going to be covered on the first midterm exam. And so my goal was to then probably have that exam be done Wednesday through Friday of the following week, something like that. I may extend it like Wednesday through Monday or something. I don't have strong opinions one way or the other on that. If people have some opinions, feel free to put up a Piazza poll and see what people prefer. Anything else? Okay. All right, let's talk about muddiest points. So it was not an extensive list this time around, so we will probably have plenty of time to take questions from the floor and from the chat. So the first one we have here is, how do I determine whether a high or low surface area is energetically favorable in water? So the idea of this is that if you have a bulk water molecule that is hydrogen bonded to adjacent water molecules, that central water molecule here, which is in the bulk area of the water droplet, can have all 4 of its hydrogen bonds satisfied. Okay. A surface water molecule is going to be missing at least 1 of those. On average, probably closer to 2 of them will be gone when it's on the surface. And so if you have a certain amount of water and you increase its surface area, to do so, by creating more surface area, you are thereby breaking hydrogen bonds. Does it take energy to do that, or does it release energy when you do that? Is it endothermic or exothermic to create, to break hydrogen bonds? Yeah? Endothermic. It requires an input of energy to do that. So since one of the principles that we learned is that systems tend towards minimums of energy, creating more surface area means you are creating a higher energy state, and so that is now destabilized. So, low surface area, meaning where you have as few sort of frustrated hydrogen bonds here at the surface of the water, is going to be energetically favorable to have as little of that as possible, as small a surface area as possible. So that drives the system towards essentially spherical droplets, because the sphere is the geometrical shape that for a given volume minimizes the surface area. That's why raindrops are round. Any clarifying questions on that? Okay. How do you know when something identifies as a solute or solvent without given any numbers or ratios? Okay, so the general idea is that the solvent is whatever it is you have in excess. Another way to think about it is that if you have the physical phase of the solution tends to be the same as the physical phase of the solvent. So salt water, for example, salt by itself is a solid, water by itself is a liquid, salt water is a liquid. And the reason for that is that there's a lot more water than there is salt. So for both reasons, you would consider water the solvent and salt the solute. But you can certainly run into cases where it's not particularly clear. You know, if you look at some high-proof vodka, for example, which might be 50% ethanol, 50% water, then it's not really clear which one is the solvent and the solute, and it doesn't really, because they're both there in roughly the same amounts. Generally, when you're dealing with a solution where water is a significant component of it, usually water is the solvent. And that is common enough, particularly in biology and environmental sciences and such, that you can pretty much make the default assumption that water is the solvent. Any clarifying questions on that? Okay. Ranking electrolytes from a list. What process do you follow? So here we have a list of examples: ethanol, potassium chloride, acetic acid, and ammonia. Okay, so in most of these cases, it's a good idea to draw out at least the molecular formula, maybe the Lewis structure of the systems in order to make sure you know what you're looking at. We've talked about ethanol enough in this class that hopefully it won't be too much of a surprise what that one looks like. Looks like this. Potassium chloride, KCl, acetic acid, and for that one you might have to go look it up because that one's not one we've talked about in incredible detail yet. And then ammonia is this. Okay, so now that we have those written out, the question we need to ask is which of these, when dissolved in water, can conduct electricity. So what properties does something have to have in order for it to imbue the water with conductivity?
Can you repeat the question?
What is electrical conductivity in general? Yes?
Could it do something along with how a molecule wants to bond or interact with other molecules?
Having to do with bonding or interacting with other molecules. Let's step back from molecules for a minute. Let's say that you have a hunk of some kind of solid and you want to know if you hook up wires to both sides of it, will it conduct? What are you measuring when you do that? Flow of electricity. What is electricity usually made of? Electrons, right. So when we're looking at electrical conductivity in a solid, we need to have mobile electrons that can go from one side to the other of the material. This is why the electron C model that we talk about with metallic solids explains the conductivity, because you can put in electrons on one side, you can pull electrons out on the other side. Now in solution, in a liquid phase, you tend to not have bare electrons floating around. Instead, you tend to have other kinds of charge carriers. So what do you think would be a charge carrier in a solution kind of situation? A charge carrier suggests two things. It has a charge and it is mobile. What kinds of things have charges? Yeah. Cations and anions, so ions in general. Ions are charged species. So the question then becomes, for these four compounds that we're looking at, which of them, when we put them in water, if any, will produce ions that can serve as charge carriers. Yeah. Lithium what? Just lithium by itself? So if you put lithium in water, you're actually going to have a violent reaction that's going to happen, and you're going to end up with lithium hydroxide dissolved in the water, and it's going to produce hydrogen gas, which will probably very rapidly catch on fire, and you'll have a very fun little demonstration. I should bring that in and do that for you guys. So yes, putting lithium into water will produce lithium hydroxide, so you'll have lithium ions floating around and hydroxide ions floating around, both of which can act as charge carriers. What about the four that we have listed right here? Ethanol, potassium chloride, acetic acid, and ammonia. Yes? Potassium chloride certainly should, yes, because it is an ionic compound. So potassium chloride, when it dissolves in water, forms K+ ions and Cl- ions. Those are the charge carriers that can conduct electricity in solution. Okay. How about ethanol? Nope. So there are no charges involved here at all, no ions involved here at all. Now, these two are tricky. They are tricky because Newton, it seems, who asked this question in the first place, seems to have assumed that you've already had a section on acids and bases, which we're not doing until a little bit later in the semester. So this acetic acid is an acid, which means that this hydrogen comes off to form H+, and this side over here forms the acetate ion, CH3COO-. And so this will create ions in solution and allow conductivity. Now the reaction is kind of an equilibrium between these two, and we also haven't quite gotten to equilibria fully yet. So it's not going to be as strong an electrolyte as potassium chloride is, because it won't make as many ions, but it will create ions. Same thing with ammonia. Ammonia will react with the water that you're dissolving it in to pull a hydrogen from that to make NH4+ and OH-. So that is going to thereby be an electrolyte as well. Similar to the acetic acid, there's an equilibrium that's going on, and so this one will also be a weak electrolyte. So the only strong electrolyte in this case is potassium chloride. Ethanol is a non-electrolyte, and these two are weak, ammonia and acetic acid are weak electrolytes. Now, it's unfortunate that Newton was asking you this particular question without you having been introduced to those concepts here. I would not ask you an exam question that would expect you to know about acid and base behavior like these until after we covered acids and bases later in the semester. Any clarifying questions on electrolytes at this point? Yes?
You might have mentioned this, I should have missed it. But the capacity, so it's acetic acid and ammonia, you said they're both weak. Does one rank above the other? Or
They're weak electrolytes. In order to tell which one is stronger than the other, we would have to know the equilibrium constants of those two reactions that we were talking about. So either the H+ coming off of the acetic acid or an H+ getting added to the ammonia. And we're not there yet. So at this point, I'm not even expecting you to know that that happens, much less be able to rank them in terms of which one's a stronger electrolyte. We will get there this semester, but you're not responsible for that yet. Okay, What is the role of a seed crystal, and does it have an effect in a solution that is not supersaturated? Okay, so this is a great question. So let's start with this term supersaturated and make sure we understand what that means before we go into talking about the seed crystal part of it. Can somebody give me an explanation of what is meant by supersaturated?
Like adding sugar to like tea when hot, like the heated up water can accept more sugar than it would when it's cold.
Right. So the idea is that when you're dissolving something in a liquid, there is a limit to how much can be stably suspended in it. Usually, if you heat up the solvent, heat up water, you will be able to dissolve more of the solute in it than you can when it is cold. Not always. There's some cases where it goes the other direction. But the example here is thinking about making sweet tea. And you can, if you heat up the tea, you can dissolve a lot more sugar into it than you can when it is, if you're trying to dissolve it cold. So then the question becomes, what happens if you dissolve so much sugar into the water that once you cool it down, it has too much in it. It has more than whatever that limit was that it should be able to hold at that point. That is a situation known as supersaturated. There is more in there than should be able to form, should be able to dissolve. And that is an unstable situation. It is simply sitting there unstably, and a slight perturbation to the system can cause the excess sugar to suddenly precipitate out of solution. So one thing you can do if you have that situation is simply wrap on the beaker, wrap on the flask. You do that, and boom, you'll have it'll suddenly crystallize. If there is a scratch on the inside of the glassware that you're using, that scratch can act as a nucleation site from which the crystals will grow. Or you can do what this question's asking about. You can add a seed crystal. So if you have one of these supersaturated solutions, and you then take one little grain of sugar and you drop it in, that seed crystal causes, is a nucleation site which will induce the precipitation of the remaining, of the excess sugar that's dissolved in the sample. What's going on here is that precipitation happens by two processes. You have nucleation and you have growth. So growth is if you already have a crystal surface, a solid surface that's present in the mixture, then growth is simply adding on more molecules or ions to the surface of it, increasing the size of the crystals that are there. Nucleation is where you don't have any such surface where crystals are already growing, and so you have to have the spontaneous generation of that first crystallite. So the thing is that this nucleation process is often harder than the growth process. And so if you have really clean glassware and you cool down a saturated solution very carefully without jarring it, then even though there's so much solute in the solution that growth would happen easily if there was something for it to grow on, you don't have anything for it to grow on, and the nucleation won't always happen spontaneously. So a seed crystal is used to get that going. Make some sense? Any clarifying questions? Okay. How do you rank entropy of gas, liquid, solid, and solute? Does it relate to enthalpy? What is meant by disorder in a system? Okay, so I know we've talked a little bit about entropy, but I haven't given you a really full explanation of it yet because we have later chapters we're going to be looking at it in. But I'm going to go ahead and give you a little bit of a preview of this idea. Let us suppose that we have a model system with 1, 2, 3, 4, 5, 6, 7, 8. We've got 10 boxes, okay? And each box is going to contain either a black marble or a blue marble. Okay? Now there are a lot of different ways that this could be arranged. That we could have this black marble over here, and so on. This we'd have all 4 of them spread out. Each particular arrangement here that we have like this is called a microstate. When we talk about a bulk system, though, we can't really see where every molecule is. We see a liquid. We may see a solution with a droplet of ink in water. So that's what this is supposed to model here, a droplet of ink in some water. Now, how many of these arrangements that we could come up with will have all 4 of these black molecules, black marbles, right next to each other? Well, they could be here. We shifted over 1, 2, 3, 4, 5, 6, 7. So there would be 7 microstates with all 4 black marbles together. Now, how many microstates are there where they are not all together? It would be all the rest. So if we think about how many total ways we could arrange these 4 black marbles and just assume that the blue ones are going to fill in all the other gaps, the first one we put in could be in any of the 10. The second one we could put in could be in any of the 9 that are left with other than where the first one went, so times 9. The third one could be in any of the 8 that are left at that point. The fourth one could be in any of the 7th that are left. So if we multiply that together, we find that there are 10 times 9 times 8 times 7, 5,040 different ways of arranging 4 black marbles and 6 blue marbles in this kind of arrangement. And only 7 of them are we calling a droplet. Okay. So if we call this droplet, and if we call this minus those 7, so 5,033, mixed, then if you just randomly put the marbles in there in some way, it is much, much, much more likely that it's going to be a mixed state than it is that it's going to be in a droplet. Does that make sense? So we call these 2 terms, mixed and droplet, macrostates. So the question for entropy is, how many microstates are there in the macrostate you're talking about? That's what we're meaning by disorder. So if you look at the mixed state, where not all of the marbles are right next to each other, there is a lot more entropy. There are a lot more arrangements that are possible that still qualify as that macro state than there are when they're all together. So what we are looking at in comparing a solid to a liquid to a solution to a gas is how many different arrangements of the atoms or molecules can you have in the solid, how many can you have in the liquid, how many can you have in the solution, and how many can you have in the gas. Now in the solid, all of the molecules are held rigidly in place. There's no rearrangement that you can really have going on in that case. And so this is going to be a very low entropy state because there aren't very many microstates that go into that macro state. The gas, on the other hand, the molecules can be anywhere in the entire volume you're looking at. And they can be, and in addition to just position, you also have to think about how much energy each one has. And so in a gas, you've got each molecule can have a pretty wide range of energies as well. So the gas is going to be a very high entropy state when we abbreviate entropy with the letter S. And so the liquid and the solution are going to be somewhere in between. The solution is going to have a higher entropy than the liquid by itself because you can now look at the solute molecules trading places with the solvent molecules. And so that adds a great many more ways of arranging all of the molecules and ways of arranging all of the energy in the system. So the general order is going to be this. Does that make some sense? Okay. Any clarifying questions on this? Keeping in mind that at this point in the class, the only thing that we're trying to do with entropy is introduce it as an idea of something that can help drive spontaneity, a spontaneous process with respect to dissolution. And going from solute and solvent separately to solute and solvent dissolved will be an increase in entropy because you're now creating a system which can have a lot more of these microstates with the molecules able to exchange positions with each other. We are going to dive much deeper into this concept in later chapters. So if it doesn't fully make sense at this point, we will be coming back and revisiting it. Any clarifications on this? Okay, so that's the end of the muddiest points list off of Piazza. Any questions of any kind from the live audience or from the chat? I have not said when I will do that, but it obviously has to happen. The question was, have I said when new videos are going to be posted? I have not said that, and the reason for that is I am hurriedly trying to make them and write the test and do all kinds of things. But yes, my goal is to have them ready by tomorrow for the next week so that any of you that are trying to work ahead for the next week will have them over the weekend to be able to look at them. Do we neglect the minimal polarity of CH bonds? Generally, yes. Yeah, I mean, I still consider it to be a polar bond, even though textbooks typically have a cutoff of, what is it? Is it 0.4? 0.4 of electronegativity. But from a practical standpoint, the degree of the dipole moment that you get from that bond is small enough that it tends to not have much of an effect.
In the quiz on often math questions, we don't have a dipole.
In the quiz octameth, I don't know what octameth is referring to. So, oh, compounded motor oil. Okay. Right, so I don't remember which compound that was actually, but essentially it's a long hydrocarbon. So it's with hydrogens coming off. So it's a long chain of just carbons and hydrogens all off of it. And so this is a case where even though each one of these has a very, very tiny dipole moment, they all kind of cancel out, and they're weak enough to begin with that you consider it to be nonpolar. So it's interesting, this kind of structure that you see here, and you'll any of you that go on to organic chemistry will become very familiar with these kinds of things. You know, if you stop at one carbon and put a hydrogen on the end, that's methane, which we know as natural gas. Go on to ethane, and then propane would be the next one, which is a common fuel that is used for outdoor grills. One more is butane, which is used in lighters. Go up to about 8, and you're at octane, and you're now looking at one of the main components in gasoline. You go out to 15, 18 long, something like that, then you're looking at a motor oil. You go out even further than that, and you're starting to look at waxes, which, as you know, can burn in candles and so on. So, so going from very small ones to very long ones, they're all flammable because you can convert this to CO2 and H2O when it burns with oxygen. But you're going from something that is a gas down to something that's a liquid, into something that's a very viscous liquid, into something that's going even further, that's a solid even. And they're all these related compounds. Anything else? Well, we can make it a short day if everybody would like to. All right, thank you all.